So today we're going to discuss, as part of the biomedical engineering program, we're going to discuss the project options. This is probably the most important aspect of your MSc course, and it should be loads of fun. So first thing, learning objectives. The projects are about you guys learning to plan. How do you plan your thesis? How do you review the state of the art? How do you explore what's already out there in terms of technology, and also for developing communication skills. So as part of this project approach, you're going to be meeting with your supervisor. You're going to have to sort of provide data to your supervisor. There's a PowerPoint presentation exercise, logbooks, and also at the end of the program, you're going to have to present a thesis and also to do a demonstration. I'll describe these in more detail a little bit further on. Obviously, there's technical skills. So when you choose your project, it's worth thinking about, what technical skills you want to learn. Do you want to go down the more signal processing and perhaps modeling side of biomedical engineering, as well in terms of jobs later, or do you want to be more the practical element, or circuit design and some of these sides of things. And then finally, of course, writing skills are really important, and that's with your thesis. But most important is this is fun. That this should be your passion. This should be your baby. This should be the thing that you want to build, over this MSc year. I'm not going to delve into these aspects too much, but the process. First, we go through the project options, talk to potential supervisors. Each of the, I've already sent around the slides, but each of the potential project supervisors, there's an email address, have a discussion with them, check to see if it's something you're interested in, and, email me your choices, preferably by the end of October. Yeah. And what I will do is I'll create an exercise where we ideally get everybody their first choice, but it may be a second choice or a third choice. I'll roll a dice if that's required. Okay. Okay. So project options. The first project option. So this is me. My core interest is in visual prosthetics. I want to make blind people see again, and I want to develop electronics which we can insert into the brain, which would allow us to achieve that. So the first project is to develop a headset. So if we're going to put an implant into the brain, we still need some kind of headset externally that will take the video stream and convert it into a form the brain can understand. And there has to be electronics which then can, take that video stream and send in a wireless data stream to the brain. So this is the first project. Now, there's a number of different directions we can go with this. There's CAD design, image processing, and embedded system electronics, and we can tune that to your particular skill. Second project, which is also on my side, is about closed loop neuroprosthetics. I'll talk about this more in my bioelectronics course, but the traditional approach to stimulating the brain is a bit like shouting at children upstairs, "Yo, kids, the dinner's ready." And the kids are busy playing with the computer games, and they just ignore mama or baba and just keep playing the computer games. And the shouting gets louder, and eventually, when the mother or the father is completely hoarse and can't shout anymore, the kids come down the stairs. Now, talking to neurons is exactly the same. This is an inefficient approach. So if you can actually have a conversation with children, if you go upstairs, stand in front of the computer screen, that will engage them a lot more. In the same way with neurons, if you can talk to them, listen to the current activity of the nerve cells, and then tune your conversation, tune your commands according to what the background is. So there's an element of modeling work here and working out neural bioelectronics. So this is a little bit more in the MATLAB, but we also have a version of this where we're developing circuits. And then the third option for me is on the field of intrabody bioelectronic networks. So the idea here is in the modern form of bioelectronic medicine, where you have little implantable nodes which provide sensing and therapy. We want these various nodes in the body to be able to communicate with each other. So this project is about developing a special communication modality to communicate between these nodes. The fourth project is by Matt Dyson. Now, Matt is really interested in bionic arms and how to improve the control of bionic arms with, for people that have obviously lost a limb. This may be due to disease, landmine injuries if they're military, or it could be birth defects. So Matt has a project looking at augmented reality prosthesis tracking, so that you can control the limb by your head movements or eye movements, such that it's not just sensing your upper muscles, but you can go, yo, arm, pick that cup up, and the arm can pick the cup up. So this is using augmented reality and hand tracking algorithms. There's an element of 3D printing and prototyping to sort of modify these limbs as well. The fifth project, also by Matt, is about developing soft fingers. So one of the problems of these artificial hands, if you like, is that in a lot of cases, the fingers can easily get snapped off. You can make them out of really, really tough metals, but then the problem is the arms become really heavy. So they tend, the manufacturers tend to use these kind of carbon fiber fingers, but they're brittle and they break. So the idea here is to look at different types of designs and work out how they can be controlled by microcontrollers, so specifically Arduinos and control motors, bearing in mind weight as well as sort of the mechanical performance. So again, this ties in with that question earlier. It's a mixture of control, signal processing, but also a little bit of mechanics. And then the final project suggested by Matt are development of EMG electrodes. So in these artificial arms, you tend to want to record some upper muscle. So you've got this artificial arm, you record an upper muscle, and by twitching that muscle, it forces the hand to respond. The problem is, how do you record that muscle activity? So you can use something called EMG electrodes, or muscle electrodes that sense the muscle activity, but they're very expensive and they're a little bit difficult. So one of the objectives here is to explore how we can use 3D printing to develop better electrodes, and then you'd have to perform electrophysiology, see what their electrical performance is. And Matt's got one final project in there, which is pattern recognition. Again, looking at how do you better determine whether a muscle wiggle means close the hand or open the hand, and just determining the difference. So this is signal processing. Project 8 is from Anthony O'Neill, and this is in the field of bioelectronic device technology. So basically, he's very interested in doing finite element modeling using COMSOL. So I think you had some of this in your core skills module, to really explore things such as electromagnetic interference between probes and their environment, heating effects, and also sort of electrical stimulation effects. So Anthony can describe this in more detail. Project number 9 is by Abhishek Banerjee, and Abhishek is a neuroscientist, but he's very interested in developing control methods to do experiments on rats where you have systems which can wiggle the rat's whiskers, shine lights into their eyes, stimulate their auditory system, and then he has probes to sense what is happening in their brains. Does when a rat makes a decision, is it based purely on an auditory sense or a visual sense? What happens in their brains as they get multiple stimuli? So Abhishek needs tools to perform these fundamental neuroscience questions, if you like. And project 10 is sort of an AI technique in the area of sarcopenia. But again, a big aspect of biomedical engineering these days is in terms of image analysis. At the moment in hospitals around the world, you've got highly trained ophthalmologists, bone people, cancer people, etc., and they have to go through thousands of images to determine if there's a particular disease present, whether cancer or sarcopenia or something else. So if we can pass this over to to an AI system, that would free up a lot of doctors' time to spend more time with the patient. So this, as I said, this is using AI AI processing techniques. And then the final option is you choose. And an example was last year, one student was really interested in diabetes and came to me, and we developed a project around a special diabetic stimulation system that would stimulate the overclock the beta cells to produce more insulin. Another student last year had an idea for bionic legs for a special disease called muscular dystrophy. And this student actually had muscular dystrophy, so he was very aware of this disease condition, and he was very keen to make a new type of bionic leg that could be applicable to people in India. So, not some really expensive 10,000, 20,000 pound, super performance leg, but something that would be more suitable, a bit cheaper, but would actually work, for children with this disease. So if you have a real passion for something, our objective is not to force you into particular areas, but let us know if you've got a particular passion. My passion is visual prosthetics. Matt's passion is bionic arms. Other people have other ideas. But if you do have a really strong passion, just let us know and we'll see what we can do. Can't guarantee you, but we can see what we can do. Yeah. Okay, so in the final couple of slides, before I open up to questions, it's worth thinking about how this year is structured. So a master course has 3 semesters, semester 1, semester 2, semester 3. And you're, in terms of how you do this project, sorry, that should be 40 credits, not 80 credits, but how you do the project is that in this first semester, this is your opportunity to choose your project, do some background reading, and think of ideas. You've got quite a few courses to do in this semester. In your second semester, this is where you do your preparation for your project. You start exploring some ideas. You make a list of components you need to order, and you have a few meetings with your supervisor, not necessarily every week, but you have a few meetings with your supervisor where you're starting to explore, work out what works, what does not work. And then in June and July, this is where you will do your project day in, day out in the labs, with, research teams, of your supervisor. And, this is where you get most of your project done. And it's worth noting that you need a full month, the full month of August to do your thesis write-up. Okay, so that's the basic structure of the of the project timeline. It sort of gets increasingly you do more and more as the year starts to progress. But I would always recommend, if you have time, don't treat this project as just a course and it's something you have to do. Treat it as a hobby. Treat it as your passion. This is going to be your pride and joy that you will show to future employers. This is my project thesis. Look what I achieved. Over this 1 year project. In terms of marking, literature review is 10%. You'll need that for next semester. There's a project presentation, which is also 10%. There's PowerPoint. There's a demonstration at the end where you demonstrate what you've. It's a live demo. You demonstrate what you've achieved. And this is not a PowerPoint presentation, but it's explaining what you've created, going through the code and answering technical questions. And then there's your thesis. And I'll leave this, these details for you. These are specific advices on how to create a literature review, how to create your presentation, and how to create your thesis. I'll leave this to read yourselves. But learning how to present your work in both written form and presentational form is really important. You're doing this master course because you want to become eventually a CTO, a chief engineer of a company, for example, maybe even a CEO. And in order to get to that level, you need to be able to paint a picture in other people's heads about what it is you're trying to create. So having these presentational skills, having these written skills are important. And I'll leave this as well. Couple of final points. So ethics. Most of you won't need ethics, but some of you might. If you do need ethics, I actually run the faculty ethics program, so I'm happy to give you any advice on this. But basically, you need ethics if you're going to work with animals, you're going to work with human tissue, you're going to work on some really sensitive military things. It's not really applicable for biomedical. Or there's an aspect of your work which deals with people. So if you're going to do any kind of trials on people, even fellow students, you need to put in an ethics submission. This is a very useful thing to put on your CV, that you've done an ethics submission. And we have a helpful process to help students achieve this. But that can be performed next semester or a bit closer to your actual project. Just remember, this is a project. This is your project. You'll have a relationship with your supervisor. I'm very active with my students. I like meeting them every week and probing them. But at the end of the day, it's your project. This is where you develop the skills to be able to work independently. And that means when you're in a company, you can, a company boss can give you a challenge, and you can go back to them and say, oh, right, this is what you need. This is how I think you can achieve this. Give me X amount of funding and, X amount of time, and I will create a device to solve this problem. And that's where you really want to be. Okay. So if you have any problems at all, we have a personal extenuating circumstances process. contact your supervisor, contact this process if there are problems. But hopefully everything will be fine. Everything will be great. These are your resources, and I'm going to open up to questions.